Hi, this is Jagruti, and my team is Gauntlet. My team member is Shiva, and we are going to present user case number one, which is poverty raised jobs and transportation in Kansas City. We have written the entire code in Python, and we have used Anaconda as IDE. This is our code, and in first step we have imported all the libraries which are needed for us. We have taken the data set which almost consists of 900 rows and 190 columns. These 190 columns are not needed for us, so we have considered only few columns which are needed for us. We almost consider like in 190 columns we have considered 50 columns which are useful for the prediction. These are the 50 columns. Starting from here, these are the 50 columns which we have considered. This is the data frame which is required for us, and dot describe will give the minimum value, like in it a column. Like if we take population, in this population column, it will give the minimum value of the population, maximum value of the population, what is the value which is present, which is at 25 percentile, 50 percentile, and 75 percentile, and it gives the standard deviation, and it gives the total number of like the columns which contain value, like all the population population column have 820 values, 820 rows. Dot info will give the data type of the column, like county we have data type object, other has data type integer. Dot head will give the first 5 rows with all the columns. Like I said earlier, we have considered only 50 columns, so it is showing like 50 columns with extra one column, this numerical column. And we have divided the entire data, like 800 rows, 820 rows, into like 80% of test data. 80% of whole data is considered as test data, and 20% of the whole data is considered as test data. This is a train data, and train data we have 656 rows and 51 columns, and we are uploading it to testfile.csv. In the step here, and this is a test data with 164 rows and 51 columns. uh, this is a train data information. In this train data, they are checking the data types of the columns. Now here we can see all the columns are integer type except the county type, county column. So this column will be considered into one data frame, and remaining columns will be updated to next other data frame, like this. This is like numerical, which consists of all the numerical data type of columns, and this is a categorical one. Now you can check the numerical dot describe and transpose. Transpose will give like columns into rows, rows to columns. These are the columns with the data type as integer. Now we are going to apply the correlation. Now we are predicting for the column black persons in poverty. These are the correlation values we have correlated. Like if we apply correlation for certain column, and for that column, when it is correlated with the same column, we'll get the value as 1. Which is more similar will get like near values to 1, and which is less similar will get values away from 1. See, now we have done correlation for black persons in poverty, and for this we can see one. Now we are taking other set of other data frame. We are considering the persons like we are considering the values with greater than 3 and less than minus 0.3 into that data frame, and these are the 10 columns with greater than minus 0.3 and greater than 0.3 and less than minus 0.3. This is the head of that filtered data type, filtered data frame for the train one. Now we are checking whether the values, whether we have any null values or not. If we have any null values, we need to update the null values with mean of that column or median or mode of that column, which is useful for us. But we don't. In this case, we are not having any null values, so we are not going to replace it with mean or median or mode. Now we are fitting like we are importing label encoder for this, and here we are using le is like a label encoder, and we are fitting this data into that by using label encoder. Now we are importing few models like linear regression model, and then uh, linear regression, decision tree, random forest, and gradient boosting regressor. And we are going to fit the whole data in all these, and we are going to check the values like scores of this data when they are fitted to any of the model. In this linear regression, like we in this from the train data we are dropping the column which we are going to predict. We are going to predict the black persons and poverty, so from the data frame we are going to drop from that column from that data frame, and then we are going to concat that frame to y data frame. And then we have use train test split, so that like if we give like test size is equals to 0.3, then test size will be 30% of the whole data, and remaining 70% will be train data. And next we are going to is same we have how we did for train data, we are going to do the same for the test data. We are checking whether these data type is categorical or integer. That columns which consists of categorical will comes under this category, and then which consists of numerical will consider to this category. And then we are going to check the values if the values are null, that will replace with the null value with mean or median or mode. Now we have imported like a few other models like decision tree, random forest, gradient boosting regressor. uh, this is decision tree, next random forest, and gradient boosting regressor. And now we are going to fit this linear regression. This is the train data, and both X-train and Y-train we are going to fit into this, and we will find the score with this train data. Same way we'll use like decision tree and we'll find the score. We are going to fit the train into decision tree and we are finding the score. And we are going to use the random forest and we are going to fit the random forest fit this data with random forest. And then gradient boosting regressor also we are using the same and we are finding the score. Then we are find like we are importing the metrics so that we can find the accuracy of that. So we have like predicted x test, y test, x test for all the models. And then we are finding the R2 score of test data for all the three, which we have got from the above, like GBY predicted, RFY predicted, and LMY predicted, and we are going to predict it. These are the files which we got, like for black poverty. These are the predicted values which we got. And this is for one column, and similarly we have done it for the household with income less than $10,000. Same, we have used the same process, like we have taken train data and test data for these columns, and then we have correlated it, and we have filtered with that correlation value. And then we have fitted the data, the train data with the decision tree, random forest, gradient boosting regressor, and we have found the scores for that. And then we have imported the metrics and accuracy scores, and we have got the R2 scores for all that predicted values. And this is for income. These are the predicted values for income. Now I'll show, like, we have collaged everything here, like black persons in poverty before prediction and after prediction, and households with income less than 10,000 before prediction and after prediction. Thank you.